Starship has already come a long way. It is the largest rocket ever developed, so massive that many people initially doubted SpaceX could ever lift it off the ground. But Starship isn't just about size. What makes it revolutionary is its reusability. For example, the Space Shuttle was limited in its heavy lift capacity and required substantial refurbishment after each mission. Similarly, Saturn V, which was a game-changer for its time during the Apollo program, was entirely expendable and left as debris after every launch. Almost all heavy-lift rockets before Starship were single-use only, becoming debris in space or trash in the ocean after their missions. Starship, however, is designed to be fully reusable, meaning every single part will be used again for future launches. Of course, achieving full reusability is easier said than done. While SpaceX has successfully reused the Super Heavy booster by catching it with the Metrizilla arms, the upper stage has so far been splashed into the ocean after every flight. Even so, SpaceX has retrieved these upper stages to test them and explore the possibility of reusing certain parts. Now Musk has announced a groundbreaking development. The Raptor engines from a previous flight will be reused in the upcoming Flight 7. This marks a significant step forward for Starship and SpaceX's vision for reusability. In this video, we'll explore all the details about this historic milestone, but before we delve deeper, make sure to subscribe to our channel for future updates about Starship and SpaceX's other groundbreaking achievements. The upcoming Flight 7 will feature the S-33 and B-14 pairing, which includes a version 1 booster and a version 2 Starship. Each Starship launch so far has used a different prototype. For instance, Flight 6 utilized the Ship 32 Starship and Booster 13 booster. The Ship 32 prototype incorporated several updates, including enhanced heat shield tiles and reinforced structural elements to better withstand atmospheric re-entry. On the other hand, the B-13 booster underwent minor upgrades focused on improving engine reliability and fuel efficiency. Flight 7, however, introduces the Ship 33 Starship paired with the Booster 14 booster. Ship 33 includes advancements such as improved aerodynamic control surfaces and a reconfigured layout for its Raptor engines to optimize thrust distribution. Meanwhile, the Booster 14 booster features enhancements to its grid fins, making them more durable and responsive during the descent phase. While SpaceX has officially transitioned to the more advanced version 2 configuration, it's surprising that the Raptor 3 engine, introduced over a year ago, has yet to make its debut. While this delay may be unexpected, it sets the stage for a significant milestone: the reuse of a Raptor engine from Flight 5, a groundbreaking step in demonstrating the feasibility of full reusability. Looking back to October of last year, SpaceX achieved a groundbreaking success by catching the Super Heavy Booster 12 using the Metrizilla arm. This was the first time such a feat had been accomplished. It demonstrated SpaceX's engineering capabilities and opened new possibilities for reusability in Starship operations. However, there are no current plans for Booster 12 to fly again, with SpaceX's shift to version 2 configurations. Retiring a version 1 booster like Booster 12 is logical. The booster deserves recognition for its role in advancing SpaceX's technology, but its engines remain relevant. Among the engines from Booster 12 is the now famous Raptor Pi, officially known as engine number 314. After Booster 12's landing in October, this engine was removed from the orbital launch mount. Recently, images have surfaced showing Raptor Pi installed on another booster, likely Booster 14. Starship Flight 7 is not just about the reuse of Raptor engines. It introduces new objectives and advancements. This flight is set to launch from SpaceX's Starbase in Texas, following a suborbital trajectory that ends with a splashdown in the Indian Ocean. The trajectory is designed to test multiple mission-critical systems, including stage separation, engine relight during flight, and the upper stage re-entry and heat resistance. These are essential to proving Starship's reliability for future missions. For the first time, Starship will deploy payloads of Starlink satellite simulators as part of the mission. These simulators mimic the size and weight of next-generation Starlink satellites. The deployment will allow SpaceX to test its payload release systems in real flight conditions. After deployment, the mock satellites will follow the same suborbital path as the upper stage, eventually burning up during re-entry over the Indian Ocean. Another critical aspect of this mission is a continued testing of reusability methods. SpaceX plans to catch the B-14 booster using the Metrizilla arms on the launch tower. If conditions don't allow for a tower catch, the booster has a backup plan to splash down safely in the Gulf of Mexico. Meanwhile, Blue Origin has once again set a launch date for its highly anticipated New Glenn rocket. While this isn't the first time they've done this, and if they delay it again, it won't be surprising. New Glenn, announced back in 2016, was initially scheduled to launch in 2020. However, a series of delays due to technical challenges and developmental setbacks pushed the timeline repeatedly, with the latest target now set for January 8, 2025. New Glenn is a heavy-lift rocket with a towering height of 98 meters, making it one of the largest rockets ever developed, though still shorter than SpaceX's Starship, which stands at an impressive 120 meters. New Glenn is powered by 7 BE-4 engines in its first stage, which use liquefied natural gas and liquid oxygen as propellants. These engines provide a combined thrust of 17,100 kilonewtons, significantly less powerful than Starship's Raptor engines, which generate 75,000 kilonewtons of thrust with 33 engines in its super heavy booster. The second stage of New Glenn features a single vacuum-optimized BE-3U engine designed for high-efficiency operations in space. While capable, its payload capacity is also lower compared to Starship. New Glenn can carry 45 metric tons to low Earth orbit, whereas Starship is designed to carry up to 150 metric tons to low Earth orbit, thanks to its higher thrust and large payload volume. New Glenn's structure includes a reusable first stage designed to land on a barge in the Atlantic Ocean, similar to SpaceX's Falcon 9 and Falcon Heavy boosters. However, unlike SpaceX's fully reusable Starship design, New Glenn's second stage is expendable. This makes it less ambitious in terms of achieving full reusability and lowering launch costs. The path to New Glenn's launch has been anything but smooth. In 2024, Blue Origin faced significant setbacks. A key segment of the second rocket was damaged due to a worker error, and a critical upper stage component failed during stress testing, resulting in an explosion. These issues required extensive redesigns and delayed further testing. Despite these challenges, Blue Origin achieved some milestones. On December 27, 2024, the Federal Aviation Administration granted Blue Origin a commercial launch license for New Glenn, valid for 5 years. This approval marked a significant step forward, allowing Blue Origin to proceed with orbital missions. The most encouraging development came with the successful static fire test of New Glenn's first stage on December 27, 2024. This 24-second test demonstrated the integrated functionality of the rocket systems for the first time, showcasing its readiness for flight. The test highlighted the reliability of the BE-4 engines, which have faced criticism in the past due to delays in their development and testing. Blue Origin plans to launch the maiden flight with the Blue Ring spacecraft, a payload funded by the U.S. Department of Defense aimed at deploying satellites. If successful, this will mark Blue Origin's entry into the competitive heavy-lift rocket market dominated by SpaceX. While New Glenn is undoubtedly a significant technological achievement, it pales in comparison to SpaceX's Starship in terms of scale, power, and ambition. That's all for today's video. Thanks for watching, and don't forget to like, subscribe, and stay tuned for more updates.